Hey y'all, today we're going to be talking about exponential integration. It's really one of our last integration rules that we're going to go over for chapter 5. So we are just about at the end. So if you recall, the derivative of our natural log function, so e to the u, it's the super awesome function that's derivative is just itself. So e to the u becomes just e to the u times u prime. So e to whatever it was stayed exactly the same, and then we just multiply by the derivative of whatever was in the power. So finding each of our derivatives, y prime for e to the 2x would be e to the 2x times 2. Y prime for e to the 3x minus 1 would be e to the 3x minus 1 times derivative of the top, which is just 3. So super easy, super straightforward. Derivatives for both of these. It was one of our easiest rules. And if it was just e to the x, then it was just e to the x. You didn't have to worry about it at all. Okay. So if the derivative of e to the u is just e to the u times u prime, then the integral of e to the u is just e to the u. But of course, because we're integrating, e to the u plus c. So just like its derivative is just e to the u, its integral is just e to the u. Okay. Now, of course, the caveat to this is if we have anything more than just x going on in the exponent, we do still have to do a u substitution for this. So let's look at number 1. Number 1, we have e to the 3x plus 1. So kind of similar to the derivative we just took. Okay. So I have something more than x going on in my exponent, so I have to take a u sub here. So my u is equal to 3x plus 1, which means du is equal to 3 dx, which means du divided by 3 is equal to dx. So plugging into our integral, and I lost my black, so I've got to add that back. Plugging into my integral, we get the integral from e to the u times du over 3, which is just 1/3 times the integral of e to the u du. And we already know from up above that our integral of e to the u is just e to the u. So this becomes 1/3 e to the u plus c. Plug back in your u, 1/3 e to the 3x plus 1 plus c. So really all I did, the integral added a 1/3. Nothing too crazy for this one. Okay. And of course, obviously a constant if we had some constant that ended up canceling out. Okay. So really, really straightforward with our integral for e to u. Even more straightforward than natural log. Now, of course, they do get a little more, more stuff added and that sort of thing. But still, should be relatively straightforward with our integral. So like looking at number 2, we have 5x e to the negative x squared. So with e, even if there's other things in the integral, typically your u is always going to be whatever is up in that exponent of your e. So once again, negative x squared looks like it's going to be my u. I have x, negative x squared, so x squared's derivative should become x. So negative x squared makes a lot of sense as our u. So u is equal to negative x squared, which means du is equal to negative 2x dx, which means du divided by 2x, negative 2x, sorry, is equal to dx. So from here, we can go ahead and plug everything in. So the integral of 5x e to the not negative x squared, to the u times du over negative 2x. So x's and x's are going to cancel out, but I'm not going to get those constants to cancel out, but that's okay. I can just bring them out front. So this becomes negative, not 2/5, 5/2. Man, I'm struggling. Negative 5/2 times the integral from e to the u du. And then from there, I can go ahead and integrate. So integral of e to the u is just e to the u. So negative 5/2 e to the u plus c. Plug back in for u, so negative 5/2 e to the negative x squared plus c. And that's it. One more indefinite integral. Integral of sine of x e to the cosine of x dx. Okay, so this one's trick. Once again, though, cosine's derivative is negative sine, so it's probably going to get that sine to cancel out. So what's up in the e makes sense as my u. So u is equal to cosine of x, which means du is equal to negative sine of x. dx, which means du divided by negative sine of x is equal to dx. So I can go ahead and plug everything in. So the integral of sine of x e to the u times du over negative sine of x. I get sine of x and sine of x to cancel out, but I'll get an extra negative. So this becomes negative integral e to the u du, which integral of e to the u is just e to the u, so negative e to the u plus c, which is equal to negative e to the cosine of x plus c. Okay, so indefinite should be pretty straightforward. Let's look at a definite integral. So definite integral, of course, I'm going to have to do a change of base because it's u substitution, but this one's relatively straightforward, e to the negative x. So almost just e to the x, where I wouldn't have to even take a u sub, but it is e to the negative x, so it's something more than just x in the exponent. So I do still have to take my u substitution. So u is equal to negative x, which means du is equal to negative dx, which means negative du is equal to dx. So basically, I'm just going to get an extra negative in there. Okay, then I have to do my change of base. So u is equal to negative 0, which is just 0, and u is equal to negative 1, which is negative 1. So this becomes the integral from 0 to negative 1, e to the u times negative du. And something I want to point out to you really quickly, notice how I still plug this limit in 0 to negative 1. So I don't switch it just because I always want to set up my integral going least to greatest. I plug it in exactly how my change of base was. So what's going to happen, I can bring this negative out front that I have right here. So this becomes negative integral from 0 to negative 1 of e to the u du. Then I got to switch it so that I go from least to greatest. So I switch it so that it becomes the integral from negative 1 to 0. But remember, when I switch, I multiply by a negative. So if I multiply an already negative integral by a negative, then it becomes positive again. So negative 1 to 0, e to the u du. Okay, I know that seems kind of wonky, but it basically ends up working itself out that it gets that negative cancel out, so we stay positive. So from here, I can go ahead and integrate. Integral of e to the u is just e to the u. So this becomes e to the u, and I'm evaluating it from negative 1 to 0. So instead of my plus c, I'm adding in my interval so I can do my f of b minus f of a. And I do not plug back in for u, so this just becomes e to the 0 minus e to the negative 1. And anything to the 0 is 1, so e to the 0 is 1. E to the negative 1, that's just the same as 1 over e. And it's free response question, so I don't have to do anything extra to combine those two, make it more, one simplified fraction. I can leave it exactly as it is. But that's that. So just a little trick there with the double negative making it positive, which sucks, but also if you miss just that one little part of the integral, then you're going to get the final answer wrong. So just kind of something to look out for. Okay, let's look at a couple more of those. So we have the integral from 0 to 1 of e to the x over 1 plus e to the x. So from here, our u, right off the bat, you should probably be like, Mr. Arbone, there's not something more than x going on. And you're correct. So this time, I'm not going to take the exponent out as my u. I have to think instead, is this derivative over itself? What's going on here? Yada, yada, yada. Well, 1 plus e to the x is in the bottom of the fraction. A lot of time, the bottom of the fraction is what's trapped. So 1 plus e to the x's derivative would be e to the x. So actually, I can take that out, and this might be our u prime over u that we looked at last class. So u is equal to 1 plus e to the x, which means du is equal to just e to the x dx, because the 1 goes away, which means du divided by e to the x is equal to dx. And it's a definite integral, so I still have to change my base. So u is equal to 1 plus e to the 0. So 1 plus 1, which is equal to 2. And u is equal to 1 plus e to the 1, which e to the 1 is just e. So just 1 plus e, which is a weird thing that we're going to have to plug in our limit, but we just got to plug in what we got to plug in. Okay. So from here, this becomes the integral from 2 to 1 plus e. And just before you ask, we don't have to end up switching this one because 2 is 2. 1 plus e. E is about 2.7-ish. So that should be 3.7. So we're going 2 to about 3.7. So we're still going in the right direction. So I didn't take out e to the x. I took out 1 plus e to the x. So e to the x, still on the top, over u, times du over e to the x. So I'm going to get those e to the x to cancel out. So now I don't have any more e to the x's or x's. And I just have the integral from 2 to 1 plus e of 1 over u du. And just like I said, this looks like that integral we did last class, which is our natural log. So integral of 1 over u is the natural log of the absolute value of u. And I'm evaluating it from 2 to 1 plus e. Okay, so from here, I can go ahead and plug in. So this becomes the natural log of the absolute value of 1 plus e minus the natural log of the absolute value of 2. Okay, from here, I can't cancel out natural log of 2. It's just going to be natural log of 2. I can't cancel out natural log of 1 plus e. If it was just e, I could get that to cancel out to 1. But 1 plus e, I can't split up that plus sign at all. What I can do is I can combine this because of the subtraction sign into a single log of the natural log of 1 plus e divided by 2. Now, you don't have to do that. Once again, if this was a free response question, as soon as you plugged in your b and your a, so this first step, natural log of 1 plus e minus natural log of 2, you're correct. So you can leave that if this is free response. I would assume probably if this is multiple choice, they would finish it out by combining it. So just trying to, kind of show you all those avenues. Okay, go ahead and pause me real quick. I want you to try and do 6 on your own. I know it's trig, it's scary, but I'll give you a hint. E to the x is your u. All right, y'all. So number 6, like I gave you the little hint, your u is e to the x, which means du is e to the x dx, which means du divided by e to the x is dx. Doing our change of base, we get 1 over e and 1, which 1 over e to 1 is still the right direction because 1 divided by about 2.7, that's going to be smaller than 1. So we're still good. So when we plug in, I know I said before that if you have multiple of your u in the problem, you can take it out of multiple spots and replace it with u. But because I still have this e to the x coming in, I only pull out the e to the x on the inside of the cosine, so I get the other one to cancel out. So you can pull out every e to the x if you're taking out that e to the x as u. But you can also leave it inside and get it to cancel out, okay? If you have a question, ask me about that in class, and I can help you with that and kind of explain you and show you some more stuff about it, okay? So from there, we get the integral of just cosine. Integral of cosine is sine. Plug in b, plug in a. Sine of 1 minus sine of 1 over e. I can't evaluate either of those things. I can't combine them because trig doesn't work like logs, so I just leave it as sine of 1 minus sine of 1 over e. Sometimes they're just gross like that. Okay, so let's talk about one last little set of integrals, our integrals of a to the u and our integrals of log base a to the u. So just like with derivatives, these are not used as often. You're not going to run into them as much. Okay, so as a reminder, our derivative of a to the u, it starts out like our e. It is a to the u times u prime, but we add in our little natural log of a. We get that extra little constant, the natural log of the base. Okay, and just as a reminder, with all of these, a is a number. Just to help us out. Okay, and then same thing, d over dx of log base a of u is the same as our natural log. It starts out the same, at least, with u prime over u, but we do get this actual, or extra, not actual, extra natural log of a down in the bottom with our u. So both of them very similar to e to the u and natural log of u, but we get that extra natural log of a term multiplied into them. So taking our derivatives, if I wanted to find the derivative of 2 to the 3x, y prime would be equal to 3 times 2 to the 3x times natural log of 2. So derivative of 3x, original, natural log of the base. Same thing, y prime of log base 10 of cosine of x, u prime, so negative sine, over natural log of 10 times, not sine, cosine of x, times the original. So nothing too crazy with those. Should be familiar. Remember, just like we learned about them in derivatives back in chapter 3, that these are kind of obscure. We don't see them as much. They could pop up as a multiple choice question, but like you're not going to get a whole FRQ that has a base of a. That's just probably asking too much. Okay. So now let's talk about our integrals. So our integrals of exponential functions with bases other than e. So the integral of a to the u, very similar to our integral of e, but we still get that extra natural log of a. So the integral of a to the u is equal to a to the u, so it stays the same, just like e to the u stays the same, but we divide by the natural log of a. So we're still getting that extra natural log of a, but this time instead of multiplying by natural log of a, like we do with derivatives, we divide by natural log of a like we do with integrals. So hopefully you're starting to notice the pattern that integrals we usually divide by constants, derivatives we usually multiply by constants when we're taking derivatives, taking integrals. So let's practice it real quick. So the integral of 2 to the x dx, that would be equal to, I don't have to do a u because I have nothing more than x in my top, so I'm just going to straight up apply my formula. So this integrates to be a to the u, so 2 to the x, divided by natural log of the base, so natural log of 2, and then plus c. So super, super straightforward on that one. Okay, last but not least, this one's going to be a little bit of a doozy, but it's 4 to the x over 2. It's a definite integral. We do have something more than x, so we're going to have to do a u substitution, and because we're doing a u substitution, we're also going to have to change base. So let's start powering through this one. Okay, and this will be the last one on the notes. So u is equal to x over 2, should be pretty straightforward, just like with e. If you got anything more than x in the exponent, it's going to be your u. So du is equal to 1/2 dx, which means 2 du is equal to dx. In addition, we have to do our change of base. So u is equal to negative 2 divided by 2, which is equal to negative 1. And u is equal to 2 divided by 2, which is equal to 1. So that's a nice little change of base. So that gives us the integral, not rectangles right now, the integral from negative 1 to 1 of 4 to the u times 2 du. So just 2 times the integral from negative 1 to 1 for u du. So now we can go ahead and integrate. Our integral is equal to, integral of 4 to the u is 4 to the u divided by natural log of 4. So 2 times 4 to the u divided by the natural log of 4. And we're evaluating it from negative 1 to 1. So from here, this becomes 2, 4 to the 1 over natural log of 4. Minus 4 to the negative 1 over natural log of 4. Okay, now, like I've said before, if this is a free response question, you could leave this like this. Okay, so if you wanted to, we could leave it exactly like this. We don't have to do anything else to touch it. However, if this was not a free response question, they're probably going to go through some steps to try and clean this up, combine it a little bit more. So let's talk about how we could do that. Okay, so if I wanted to, I can change this 4 to the negative 1 to be 1/4. So this is equal to 2 parentheses 4 over natural log of 4 minus 1/4 over natural log of 4. Okay, then I can distribute in that 2, so that gives me 8 over natural log of 4 minus 1/2 over natural log of 4. Okay, if I got these both to be in the same size, 8 over natural log of 4, that's the same thing as 16 over 2. over natural log of 4 minus 1/2 over natural log of 4. Okay, 16 over 2 minus 1/2, that's equal to 15 over 2 over the natural log of 4. And 15 divided by 2, I can move that divide by 2 down to the bottom. So this final answer is the same as 15 over 2 natural log of 4. And I ran quite a bit out of room down there at the bottom, but that would be our final answer, 15 over 2 natural log of 4. Now that's super gross, okay, but all I did is just kind of distribute and combine like terms in my fractions, get common denominators, that sort of stuff. So none of the math I did there was super, super crazy. But with that being said, y'all, that is exponential integration. Pretty straightforward. I don't want you to freak out too much about these last couple with A's. If you're like, Mr. Arbone, I don't really feel super great about those. Just like they are with derivatives, they're pretty obscure. They're not going to show up a bunch. So the biggest thing is if you can do your E's.